Good evening, everyone. Welcome to the session. We will wait a couple of minutes for others to join, and as usually, our sessions do extend. So, I guess we can take a couple of minutes from the beginning, right?
Yes, sir.
I hope you guys can see my screen clearly and hear me loud and clear, right?
Yes, sir.
Okay, thank you. Uh, so, anybody who is joining the session for the first time?
No, sir.
Okay, so this is the fourth session, kind of. By the end of this, we will be halfway through our interaction sessions. Any doubts regarding previous assignments that you have already submitted? Guys, this is an interactive session, so I would request you guys to use your mics more often. I guess three assignments have been already
Fourth one,
Yep.
sir. 370 is done. Fourth one is pending.
Okay. So any doubts in previous assignments or fourth week contents, or till fourth week, any doubt? Anything that you would like to discuss?
No, sir.
Okay. Let's just wait a couple of minutes to see if others join. So, already completed week 4 of Sir's lectures, and today we'll be doing uh, problem solving for that session. Uh, how are you feeling doing completing half of the course? Is it up to your requirements? Is it satisfying for you?
Yes, sir.
Okay.
The questions are a bit tricky, the assignments, but it's up to
Assignment.
the
Which kind of questions have been tricky? I mean, I didn't.
for example, the assignment to that estimation question.
Yeah, estimation question is basically you have to draw each and everything,
Yes.
and then and only. Yeah, it takes time. Other than that, I mean, that was lengthy. You can't say tricky. I mean, there were no googlies there. Okay, any other question? See, we did construction economics in 1 week. For that, even Sudhir Misra sir has a full 8 week course on NPTEL. So, solving that week's assignments, how was it? Okay, we'll just wait 20 more seconds. We will start by 6:05. I won't keep you waiting for long. Okay. Good evening, everyone. Welcome once again to the problem solving sessions for the course Principles of Construction Management. The course instructor is Professor Sudhir Misra from IIT Kanpur. I am Gopal Mahajan, a PhD fellow at IIT Delhi. So in this course you have already been through 4 weeks now. This is regarding fourth week problem solving session. You know that you would have felt that the course is quite broad and in-depth study is required from your end, but for covering the diverse topics, for giving you an idea of what actually is happening, this I guess you would have liked it. Now coming to the plans and coming to the weeks we have, uh, first week was general overview, second week estimation of project cost, third week construction economics. Now fourth week is planning and scheduling. This is kind of my topic till now in taking problem solving sessions, because like I have taken one course, scheduling techniques in projects by Professor Uma Maheshwari, that goes very deep into scheduling techniques, specifically information driven scheduling. Then there is another course by Professor Koshi Vargesh, project planning and control, that also basically deals with uh, project scheduling. So we will be discussing project scheduling in this session as well as next session, but the planning part would be completed in this session itself. Next session would be more of control and crashing cost aspect. So regarding the duration of activities, we already did something like that in estimation of project cost, if you remember, that we had quantum of work and then we had productivity rates. From that we found out the durations, and from duration we went into calculation of cost and all, right? So let's come to the contents of this session. There is one topic remaining from construction economics, loan repayment. Then we will go into network basics, AOA, AON networks, critical path and total float. We will be limiting ourselves to total float. If you want to go into detail, just ask for the link. I will share you that. And then we will see the overview of PERT. Okay, so loan repayment. Why are we discussing this? Okay, you guys know about EMI, right? What is EMI? Anytime you purchase some big item from Amazon, Flipkart, you will get an option of no cost EMI or something like that. Or even if you have a big credit card purchase, the credit card company itself would offer you to provide EMI at what, 13%, 15% rates. So what is an EMI?
So the monthly installment.
Equated monthly installment.
Okay, equated monthly installment. So you know that, I mean, this is kind of a हिसाब बराबर thing. अगर हमने किसी से कुछ लिया है तो देना तो पड़ेगा, और and here we have to pay with interest. So let's see. In an interest repayment structure, which part of each payment is prioritized? So as you know that, okay, if there is sorry, yeah, if there is some loan, so your total amount would be principal plus interest, right? So what the question here is, in an interest first repayment structure, like EMI is also a repayment structure, right? That is an equated monthly installments. It could be annual also, it could be semi-annual. So which part is prioritized? As the name suggests, interest part is prioritized. So what is happening is that if you are paying some amount as a repayment, it first caters to the interest component, and then if something remains, it caters to the principal component. Okay. What is the primary characteristic of a principal first repayment? So as we saw right now, right, A is equal to P plus I. So that was interest first. This is principal first. So what is the primary characteristic?
Faster loan repayment.
Faster loan repayment, definitely. Yeah, see, as soon as your principal reduces, your upcoming interest rate also reduces, right? So your total interest cost reduces. It is not higher, it reduces. As soon as you pay off the principal, you only have to take care of interest component, right? So instead of extended, it reduces your loan repayment. What is this lower initial payment? See, you will find that yeah. Any idea about what is this initial payment, lower initial payment? This basically talks about what principal component you are actually paying off. So if it is principal first, then it is going to be higher initial payment. Okay, so we have got faster loan repayment. Okay, now just another true false, we will be quick. Borrowers who opt for principal first repayment typically experience lower total interest cost over the life of loan. Yeah, so lower, this is true. What about this? In an interest first repayment structure, the initial payment are typically higher. We just saw that they're lower, so this is false. Right. Now, coming to a numerical, you will find this kind of numerical. I think this was not there in this year's assignment, but previously this used to be a part. Okay, so choose the correct option from the following statement regarding the time required for the repayment of a loan which is to be paid on an annual basis. Consider the loan amount of rupees 15 lakh, rate of interest is 12%, the annual repayment amount is rupees 1 lakh 80,000. Okay, so if I P is 15% and rate of interest is 12%, what is I? Annual?
More like 80,000, sir.
It is coming to be same, right? 1.8 lakh, and that is your annual repayment amount. So whatever the interest you are generating is what you are paying back. So let's see the option. The time required to repay the loan is maximum when the repayment is used to pay the principal first. The time required to repay the loan is maximum when the repayment is used to pay the interest first. Okay, let's discuss this. If you are paying the interest first, what will happen is your interest is 1.8 lakh each year, and you are also paying 1.8 lakh. So your principal is remains untouched. So that means your repayment goes eternally, right? Your principal is not even reducing. So it is maximum. Time required to repay the loan is maximum when repayment is adjusted to partly pay both interest and principal. So this one would be minimum, right? Like of 15 lakh, if you are paying 1 lakh 80,000 in the first year, so next year itself you will pay interest only on 13.2 lakh, right? And this will be somewhat in the middle of A and B. There is insufficient information. Well, we just gave the answer, right? So this cannot be the. So now coming to some interesting things again. Network. So what do you mean by a network? See, this topic is like, if we go into detail and we discuss, there would be so many good things coming out of this. Okay, what do you mean by a network? Just general. If you talk to some person, you have been on social media also, that is a social network. So what do you mean by a network?
The link between two particular things,
Okay,
two or more.
so two or more and link. So can there be multiple links also?
Yes, sir, definitely.
Okay, then should this link be directional or just a link, non-directional?
Directional.
Why? If you are friends with someone, then it is a non-directional link, right?
Yes.
Then see
So
network. Yeah, yeah. You were saying something.
no, sir.
Okay, so in our case, what is happening is we will be taking directional links. So how will we be drawing is we will be drawing with the help of events and activities. So event is an instance of time, okay, and activity the whole duration, the passage of time. So what we have here is we have one activity, okay. This is a link. So if it is an activity, it is taking some time, it is consuming some resources, yeah, there is some cost associated with it. So if this is an activity with passage of time, there is a start event when the activity starts, and there is a end event when the activity ends, finishes, right? So when you have got this type of network, let me give you an yeah, a activity a is 5 days, let it be 1 2. So this is start event, finish event, activity showing its duration. Then there could be another activity uh, going to, and this time 2 becomes the start event for next activity, right? And there could be activities like this also. This event could be diverging where more than one activities are coming out of it, right? So this is one kind of representation. But which kind of representation is this? This is AOA, activity on arrow. We represented activity on arrow, right? But if the same thing we want to do with activity on node, let's see how it becomes. There is activity A, then see what just happened. Activity B follows activity A, activity C follows activity A, right? So now you have got activities on nodes. This is activity on node network, AON representation. Okay, so in this case, you knew that the circles represented the events, and in this case, they represent the activities, right? In this case, the arrow represented the activity. What does this arrow represent? What does this arrow actually represent? In first case, it had a lot of components, like it represented some duration, passage of time, there was some consumption of resources, and all the things attached to an activity. What does this arrow in AON network represent?
Completion of an activity.
Okay, ma'am, let me make one change. I am not talking about this end itself, okay? Let it be this complete arrow. What does this arrow represent? Still, does it represent the completion of activity? But if it represents completion of activity, which activity? Because two are connected here.
It shows that A is the predecessor.
In
A is the predecessor here.
Okay. So what this error actually represents here is that there is some relationship between activity A and B. What kind of relationship? The relationship here is that when activity A finishes, activity B can start.
yes.
Right? So finish start relationship is being shown here. Okay. So let's try to solve some numericals. But first, some KBC, some small questions. Okay, which of the following statements about the critical path are true? Is true. What is a critical path? Options are in front of you, A, B, C, D. You can directly give answers.
Shortest path to complete a project.
Okay, is it the shortest path or longest?
Longest.
Longest path.
Uh, okay. Mm, so, which is the correct option? A, B, C, or D?
C.
C.
I think B, activities on the critical path have zero float.
Okay, so we have got one new term float here. Okay, so there was a confusion between shortest duration and longest duration. Okay, so let me make a network for you guys, and we will see if it is shortest or longest. Okay. You all can follow this network, right? What kind of network is it? AOA or AON?
AOA.
AOA.
AOA. So how many paths can you see in this network? You have got path AB, right? That is 1, 2, 3, and then you have got C, right?
Yes.
So if these are the paths, what are the duration? For AB you have got 7 and C you have got 5. So what do you think about option A now? The critical path represents the shortest duration to complete the project.
Longest AB.
Okay. So I would request you guys to just forget the shortest longest path. What is given here is to complete the project. Okay, this is the whole project. Can you complete the project in 8 days? If you have been given 8 days, can you complete the project? I mean, definitely you can complete the project.
Yes.
Even one day
Yes,
is
sir.
extra for you, right? So, can you complete the project in 7 days?
Yes.
Yes.
Can you complete the project in 6 days?
No.
No.
So, doesn't it makes that 7 days you can complete it in 9 days also, right? So, 7 days is the shortest duration to complete the project. Can you agree on this? I mean, below 7, if it is 6 or 5, you cannot complete the project, right? So, does it
Yes.
make sense? 7 represents the shortest duration to complete the project. Okay, still there is some confusion, right?
It's a minimum number of days will be required.
Yeah. So, minimum means shortest, right? Shortest duration.
Yes.
See, there are two definitions you can say: shortest duration to complete the project, and longest path. Okay. So 7 is the longest path here, and for completing the project, it is the shortest duration. So A is correct. Now, let me change the duration here. What if C is 7, and so which is the critical path now? A, B, or C? Path 1 or 2?
Path 1, sir.
Okay, there is one vote for path 1. Anybody else? I mean, I just increased the duration of activity C such that now both paths have the same duration. So you still agree that path 1 is the critical path? Okay, why do you need a critical path? What do you mean by the word critical? Just vernacular language. No need to go into technical detail. What do you mean by if you say something is very critical?
Critical means we can say it's very important.
Okay.
Which cannot be
And
delayed.
yeah, and if we alter on that path, then the duration of the project will get altered.
Okay. So in this case, you have got two paths, A, B, and C. Even if you alter any of the path, like if you increase your duration of A by 1, your project duration change. Even if you increase the duration of C by 1, your project duration changes. Right? So then which is the critical path? Okay. So you should keep in mind that there is nowhere written like that there can be only one critical path.
It is both, I think. Both.
Yeah, both are critical paths. So you can have more than one critical path. Hope you agree with this. Then activities on the critical path have zero float. We will see float calculation. The critical path is not affected by changes in activity duration. We just changed the activity duration and critical path changed, right? So it is wrong. Critical path activities can be delayed without affecting project completion. No, we just saw this also, right? So now coming to dummy activity. It is a dummy activity, zero cost, zero resource, zero time, right? Mainly zero time. So okay, how do you represent a, how do you draw a dummy activity?
Dotted line.
Okay, dotted line. So when you have got straight lines, let's say 1 2 2 3 4, so no, this cannot, wait a minute. Yeah, so this dotted line is showing a dummy activity, right? So what is the primary reason for using a dummy activity? To improve the diagram aesthetics, I mean dotted lines, obviously.
C.
C, to clarify complex dependencies. Okay. uh, to identify critical paths, not so much. To indicate a task with high risk, we saw that we are not even in this case. If you had to highlight the critical path, what you would have done is you would have drawn over it, right? That is one way of presenting it. So yeah, to clarify complex dependencies. What do you mean by complex dependencies? Or this was just the elimination, like it cannot be this, it cannot be this, and it cannot be this, so it is C. Okay, so we will draw some dummy activities and see. That would be a better way. Okay, when using dummy activities in a project, what does it mean when two real activities are connected by a dummy activities, by a dummy activity? See, right now what was happening is when I drew this, you saw a dummy activity between two events only, right? I mean the initial logic is that between event 2 and 3 there is a dummy activity. So now we are going into something a little technical. What does it mean when two real activities are connected by dummy activity? That two real activities are unrelated, two activities have finished to start relationship, the two real activities can be performed simultaneously, or two real activities have start to start relationship. Okay, so let me draw something for you guys. There is activity A, then there is activity, then there is a dummy activity, and there is activity B. Okay, so if you see this dummy activity, what is it presenting? Activity A finishes, then activity B can start, right? Finish to start relationship. So not unrelated, not simultaneously, not start to start, finish to start. Okay. So coming to a network here. Common data question. For the network consisting of 8 given activities, draw the network and answer the following questions. The first question is total dummy activities are. Tell me one thing. Can dummy activities be there in activity on node network?
No.
Okay, so I've got no, and Okay, do you guys want me to elaborate this, or I will let it be? Okay, so if activity on node network cannot have dummy activities, and the question is to calculate the total number of dummy activities, that means you have to make AOA diagram here, right? Even if it's not given in the question, because there is a question of dummy activities, that means you have to draw a AOA diagram, activity on arrow. So what is the first step now? How can we draw this? Or can we just start randomly drawing? I guess we can do that, right? Random drawing also. Let's say what is this? What is it saying? Activity A and activity B start simultaneously, have no IP, they are the starting activities, right? So A, B. What about activity C and D? C and D follow activity B. Right? What about activity E? E follows A and B. So if activity A is ending here, for E to follow A and B, we will have to introduce some dummy activity, right?
Yes.
Right? So let's introduce this dummy activity. What does this mean? We at this event, when we reach this event, activity A has also completed and activity B has also
We
finished,
also complete.
right? So we have got activity E now. What about activity F, G and D, H? F follows activity D. Okay, this looks clear. What about activity G and H? G and H, C, D, E. Okay, let me draw it separately. Then we will see if there are some alternatives. Okay, so we have got activity E, F, and what? Yeah, D, E, F, right? So let me change it to D, E, F. D, E, F, and similarly we have got which one? No, no, no. Just a minute. We have got C, D, E, right? Which we have to target. Yeah, E, C, D, and we have got F, G, H. Let's try to connect them. Okay. Activity F can start when activity D finishes. So let's just change the order, H and F, and connect it with dummy activity right now. We'll compress it later. Activity G, C and D. So C and D means what we did for AB. Let's do it again. Yeah, this means that activity D is also completed, and this would give you G. What about activity H, C, D, E? If we come to this event, that means C and D has already finished, and if we make another dummy activity here, that means C, D and E, all three are completed. Can you follow this? What we did with this dummy? Can you follow this?
Yes.
Yeah. So from E, so that means if we have the start event this, that means C, D, E are the predecessors for H. Now let's try to remove the extra dummies. In this case you don't need a dummy, right? You can directly link it here. Similarly, it seems the same. You don't need the dummy here. Now there are 3 dummies. Can we remove any of them?
Yes, that's a C and G we can remove.
Okay, C and G we can remove. Let's see. If you remove this, yeah. What does this mean now? Is it the same? does it still mean that C and D are the predecessors of G? Yes, it does, right? I mean, what is the confusion here? It's so simple.
Yes, sir.
See, the thing is that network logic should remain. That is primarily. That is primary. So even if you read it like this, G, what are the predecessors for G? Two incoming arrows at start event. C and one dummy activity. That dummy activity is from D. So CD, right? This is the same. So now if you have to combine it, so what it could be?
It's very basic.
This seems like this. So let's try to complete the network. And as we have to solve, I will draw it in a bigger page. What we have got? Activity A, B coming here. From activity B again we have got C and D. And from activity A we have got what? This we have got activity E and a dummy activity here. And from D we have got what? F. Let's say there is our finish event. From C and D we have got G, and from CDE we have got H. Right? You all agree? So let's try to answer the questions. What are the total number of dummy activities? 1, 2 and 3?
3.
Right? 3. Now coming to the question, the total duration and critical path. Okay, before that, there is one thing. When we were drawing here, even we would have been naming the events, right? 1, 2, 3, 4, numbering the events. So how can you number the events right now?
One, two, 3.
1, 2, 3, 4, right? So let's try numbering the events first. I'm just I will tell you what I am drawing right now. Yeah, so in this case the representation I am following is this is going to be your event number, this is going to be your early time, this is going to be your late time for the event, right? EET and LET, and this is going to be your slack. This representation we are using. Any questions regarding what EET is, what LET is? Okay, we will see to it. First step, numbering. So numbering, this is the head event. Oh, sorry, this is the start event. So this becomes 1, which should get 2 now. This event or this event? At the end of activity B or activity A?
B.
B, right? Because there is still one incoming arrow at this event. So this becomes 2, this becomes 3. Now what? You can name which event now? This has got incoming arrows. So this becomes your 4, 5, 6 and 7. So you have got 7 events. Now network calculation, network analysis. So you have got forward pass, and you have got backward pass. So we will start with forward pass. Let me do it in another color. So start event, earliest start of event 1. When should event 1 start? When can event 1 start? Or sorry, it is not starting. When can we reach event 1? Because it is an instance of time, right? It is the starting event. So at time 0. What about B? The duration of B is how much?
6.
Let me write the durations first. So that would make, we don't have to look at the table again. C is 5. D is how much? 3. E is 7. Guys, you will have to check if I am writing the correct duration or not. Okay, so duration is written. So 0, 6. So 6. When can we reach event 2? At 6, right? What about event 3? Either we can reach by this way 3 or this way 6. So earliest we can reach by only after activity B is complete. So this becomes 6. What about event 6? Another incoming arrow. So let's go to event number 4 by numbering, right? Event number 4. When can you reach it? 6. 6 plus 3, 9.
9.
What about event number 5? Either it could be 6 plus 5, 11 or 9. So you can reach by 11, right? 6 plus 5, 11. At the latest, when all the... See, what do you mean by an event is that all the predecessing activities are complete. So if you are reaching event 5, that means all the predecessor activities must be complete. If you reach there in 9 days, you can see that activity C still remains by 2 days, right? If you reach this event by 9 days, that means activity C is still pending. Activity C is not yet complete. So earliest when can you reach? When can this event be said done? Instance of time when all the predecessing activities are complete. So 6 plus 5, 11. Similar thing, 11. Either it could be 11 or 6 plus 7. What is the number here? 13. So 13. Then 6. Then event number 7. What could it be? 13 plus 6, either 19. 11 plus 3, 14, or 9 plus 4, 13. What would be? 19, right? So from this itself, can you say that the duration of activity, the total duration is 19 days? Can you comment on it? Okay, this was your forward pass. Let's do backward pass. So what time at this is the latest event time, right? So this would be 19 for end event. 19 minus 4, 19 minus 3, 19 minus 6. Or will there be any change? In backward pass, what we would do is we would follow the arrows backwards. So from the head of the arrow, we will go towards the tail of the arrow. So 19, 19 minus 4, how much is it? 15. Only one tail or two tails. There are two tails. That means you cannot write it directly, right? Two tails, right? Same here, two tails. If you take this, only one tail. This is the only one tail, right? And in case you have got two tails for this event. So 19 minus 6, 13. Now coming to this point, from this you have got 16, and from this tail you have got how much? 13. So minimum in this case 13, right? It is backward pass, so we'll be taking minimum values. Now from this tail you have got 13 and 15, so it becomes 13. Can you guys follow the backward pass? Okay, so now coming to this event number 2, you have got three arrows. So then let's see event number 3 first. Only one tail, right? So 13, 13 minus 7, 6. Now 3, which one? 13 minus 3, it could be 10. or 13 minus 5, it could be 8, or it could be 6. So minimum value 6. Similarly, coming to event number 1, 2 arrows, right, 2 tails. So either it could be 6 or either it could be 0. So 0. Backward pass done. Okay, so backward pass is done. You have got early event time, you have got late event time, you have got event number. What is the slack? Okay, so slack is equal to LET minus CET, right? You just need to subtract it. Let's put the values 0 0 0 0 2 what 4 0. Okay, so we have got slack calculation also. What is the critical path? How can we find the critical path in this? Anybody, what is the critical path? Can you see? Or let's do one thing.
Value 0.
Okay, slack value 0. That is one way. Slack value 0, let's go. Then it becomes 1, 3, or it could be 1, 2, 3, 6, 7, right? There are two options now. 1, 2, 3, 6, 7, or it could be 1, 3, 6, 7. See, if you just see this 0 slack, you are getting two paths. Which one of them is correct? See, that's the definition that you gave to me. 0 slack. We did that. Yeah, you will find that slack can give you multiple options, but if you have the definition that total float should be 0, then if you check the total float, you will find the better alternative, one single answer. Okay. Uh, so the question is, what is the how can you calculate the total float for each activity? So total float is equal to late event time of the finish event minus early event time of head event minus duration of activity. Okay. What is the total float? Total float is the okay. What is the total? What do you mean by total float, or what do you mean by float?
Number of days the project can be delayed.
Project can be delayed or activity can be delayed.
Sorry, activity.
Okay, so number of days activity can be delayed, but activity can, okay, by your definition, let's say activity can be delayed by 20 days. Does 20 day become its total float? You said na number of days
No.
an activity can be delayed. I am saying that activity A can be delayed by 20 days. Is delayed by 20 days. So does 20 days give you the total float?
So other activities may be delayed.
Okay. So you can just update your definition that a number of days an activity can be delayed without affecting the total project duration. Okay. So let's suppose this is I, this is J, this is 10. EET, LET. EET is 9, LET is 16, EET is 35, LET is 40. So, is this a possible scenario? Only if there are some other incoming arrows, right? So, what does this show is activity at the earliest we can reach the start event of activity A at ninth day, at the end of ninth day, right? So that means and at the latest we can reach its start by 16 at the end of 16th day. What does this EET mean? That means that till 35 if you complete it, at the earliest you can reach the head event of or the finish event of activity A by 35 days, end of 35 day, and at the latest you can reach by 40 day without affecting your project duration. So that means the total float here becomes TF for A is equal to 40. At the latest you can finish by 40. So when can you start? By duration. And what is the remaining scope now? 9, right? So how much is it? 21. Total float is 21. Can you guys follow, or do you need some more explanation on this? Okay, so if you guys can follow, let's try to calculate float for each activity. Let me change the color to black now. Okay, I'll write it in bracket first. For A, how much is the early 6, 0, 3? This becomes 3. For B, how much is it? 6, 6, 0, 0. For E, 13, 7, 6, 0. For C, how much is it? 13, 6, 2 and 5, 2. For D, can you guys follow the calculations? 13 minus 6 is 7, 7 minus 3 is 4. For activity G, 19 minus 11, how much? 8, 8 minus 3, 5. For F, 19 minus 9, 10, 10 minus 4, 6. For H, 19 minus 13, 6 minus 6, 0. Okay, so you have got your float calculation also. Now you can see that if you follow this path 1, 3, 6, 7, there is activity A 1, 3, 1, 2, 3 that has some total float, right? So this is not your critical path. If you follow this 1, 2, 3, 6, 7, the activity B, then the dummy activity, then activity E, then activity H, all these activities have 0 total float. So what is your critical path now? B, E and H, right? So let's answer our questions now. And which is the activity with maximum float? Activity F with float 6, right? So let's write it. Total number of dummy activity is 3. Total duration is 19 days. Critical path is what? B, E, H, right? That was our critical path. Activity maximum float is F, and value of maximum float is 6, and unit is days. Okay. So yeah, now that was a AOA network diagram. Let's try to solve this for an AON network, activity on node network. Let me give you the representation here. You have got activity, you have got its duration, then you have got early start time of activity, early finish time of activity, right? So EFT is equal to EST plus duration. That is your forward pass. Then you have got late finish time of activity in your backward pass, and LST. LST is equal to uh, LFT minus duration. Then you have got your total float written here. So what is your total float now? What is the formula for total float now? Same as before, right? Late finish time. So the total float becomes LFT minus EST minus duration. Okay, so you have got all the formulas. Let's try to calculate it. What is this PS and what is this PF?
Start and finish.
Yeah, why do we need this? Why are we need? I mean, there was no talk of start or finish event or start or finish activity in case of when we were discussing how to draw the network. Then why are we having these? Just to make some sense, right? Right? Just to have some logic. Okay, we will see how to use them. Okay. So uh, let's write the values here. We start at 0. So early start time for activity A 0, this following this arrow. Now early finish time 0 plus 13, 13. Similarly for activity B, the early start time now becomes 13, 13 plus 17, 30. For activity D, there are two arrows, so we will have something else. 0 for activity C, 0, 0 plus 15, 15. In this case, either it can be 0 or 15, but all the incoming arrows should be complete, so that would be maximum value, right? 0 comma 15, then this becomes 15. 15 plus 30, 45. What about activity E? It can start at 15, right, and finish by 25. What about activity F? Either it could be 45 by this arrow or 25 by this arrow. So taking the maximum one, 45. 45 plus 20, 65. Coming towards G, 30. Either it could be 30 or 45, right? From this arrow, 30 or 45. So we'll take the maximum one, 45. So this becomes 60. So when does your project finish? Either 60 or 65. So earliest you can reach by 65. Hopefully you guys can follow the forward pass. Now let's try the same backward pass. You have got no restriction here, right? When the project can finish. So if there is no restriction, we'll take the same 65. 65. So going towards the tail of the arrow, this becomes 65. This is again 65. Subtracting the duration. How much is it? 50. 45. Now two tails here, right? So either it could be 45 or 50. So minimum one, 45. This becomes 15. Similarly from here, only one tail, right? So 45 minus, so this becomes 45. 45 minus 10, 35. Yeah, so coming to activity B, 50. So this is 50. 50 minus 17. How much? 33, right? So 33 minus 13 is 20. Similarly, two arrows, either it could be 15 or it could be 35, so it becomes 15. This is 0, right? So now let's calculate the total float. Total float, checking the diagonal, 33 minus 0 minus 13, 20. 50 minus 13 minus 17, 20. 45 minus 65 minus 15, 5. 45 minus 65 minus 20, 0. 15 minus 45 minus 10, 20. 15 minus 0 minus 15, 0. And 15 minus 45 minus 30, 0. Yeah. Can you guys follow this? So you have calculated the total float and critical path, the ones with 0 total float, right? So it becomes, critical path is what? C, D and F. Yeah, I know. I mean, somewhat boring calculations, but did you get an idea of what happened? So my question to you guys is, why did we do all these things? Forward pass, backward pass, we calculated the critical path. How do you see it on site? How does it help you on site practically? Question is simple. How does this
Which
help?
activities we need to put more resources or manpower into?
Um, okay, putting more manpower or more resources. What do you mean by that? I mean, give an example. Take any activity in front of you and tell me how is it helping, how is it changing. Just, just, uh, just take any example. I mean, talk hypothetically. Let's pick activity A. If you increase the manpower, what will happen?
So not manpower. I mean the critical part will determine the shortest duration, right?
Okay, the critical. You have got the shortest duration. Then what?
So sir, we can determine the float, and after that we can determine in which activities like the critical part cannot be linked with the float. So
Okay.
which activities that we have found out the float rate. So yeah.
Okay. So what you have got is that after doing all these calculations, you know that if activity C, D, or F that lie on the critical path, if you delay any of these activities, your whole project will get delayed, right? You agree?
Yes.
But what if activity G delays by 10 days? Okay. See, as soon as you delay your activity G by 10 days, so this becomes 25. So 45 plus 25, how much is that now? 70. So instead of finishing it in 65, you will be finishing it in 70 days. Right? Your project duration changed. If your activity G delayed by 10 days. So you can see that total float is giving you an idea of what relaxation or how much float you actually have for each activity. Like if activity A delays by 15 days or 18 days or even 20 days, you are sure that it is not going to affect your total project duration, right? But if it delays by even 21st day, you know that that one day is going to be seen in your project duration. So that is one way of looking at total float. Now you have got two types of values here. Either you have got zero total float or you have got some numerical value, positive total float. Can you have negative total float? Can you have negative total float? My question is simple. Can you have negative total float? Okay, so let's try to solve this the same network with added point. Calculate total float for activities of the following network if it has to complete in 60 days. Okay, so I'll be writing the values. You help me check. 0, 13, 13, 30. This becomes 0, 15, 15, 45, 15, 25, 45, 65, 45, 60, 65. Now you have got this 60 has to complete in 60 days. So that means your latest finish time at project finish, latest time, how much is it given to you? 60 for backward pass, right? 60. So let's try it. 60. So this becomes 60. This is again 60. 60 minus 15, 45. This becomes how much? 40. And coming here, 40, 30. Two arrows in this, one arrow in this case, right? So 45. What is 45 minus 17? Are you guys even here? And you guys are here, right? I see a handful of you, like 8 or 9 of you here. Okay, so now two backward arrows from this side, 45 and 40, minimum value 40, 40 minus 30, 10. Here two backward arrows, 10, 10 minus 15, minus 5, right? And if you follow this, okay, you haven't answered this. 45 minus 17. Okay. Minus, so this becomes 28. So,
28.
and how much is this now? Right? Okay. Have I written correctly?
Yes, sir.
Yeah. So let's calculate the total float now. I'll write it with black. 28 minus 0 minus 13. It is now 15. So 45 minus this is again 15. What about this? This becomes 0. 40 minus this becomes minus 5 now. Right? This is also minus 5. For this, 40 minus 10, 30, 30 minus 15, this becomes 15. 60 minus 20, this is again minus 5. Yeah, so you saw that you can have negative float, and you also saw the condition, right? Okay, so any questions till now? Any questions? Okay, so guys who joined late, do you want me to give you a recap of what happened till now? What we discussed? Or the guys who joined late or others also, do you have any specific doubt regarding the contents till now or the assignments that you already submitted? Guys who joined late, do you want me to revise from the first slide again? You guys can hear me, right? Okay, anybody? Can you guys hear me clearly?
Yes, sir.
Okay, so thank you. And if we are not going to have any recap, let's move forward. So, till now, what we have discussed is we have discussed loan repayment. Yeah. Then
Yes, sir.
AOA, AON.
Yes.
So, what is remaining is PERT is remaining, right? So, let's see some quick questions on PERT. What does PERT stand for? A, B, C, or D? Project execution and resource tracking, program evaluation and review technique, project estimation and risk testing, project evaluation and resource tracking. A, B, C, or D? What does PERT stand for?
B, sir, B.
B.
B, right?
Yes.
Okay, so as you guys already know about PERT, can you guys tell me about the history or the origin of PERT? Okay, mm, anybody? Or let's take an example and see. But for this example, there is one condition. Can everybody of you please turn on your mics? Yeah, thank you. So, so we will be doing a design of a house, right? So there will be architectural drawing, there will be structural drawing, and there will be MEP drawings. So, how long will it to take take to complete architectural design of G+2 house? Everybody, just give me answer.
Depends upon size.
Just I'm not worried about variables right now. Just give me a timeline. Any
10
timeline
days.
would work. I don't
10
want it to
days.
be accurate.
10 days.
10 days, right? So we have got. Okay, we'll be talking in terms of days. Okay, 10 days. Anybody else? Can everybody finish it in 10 days, or somebody would need less days or more days? See, it is up to you guys. Just give me some answers, some values.
11.
Okay, so you will take 1 day extra for checking, right? For giving the
Yes, sir.
perfect drawing. Okay, so anybody else? Like we have got one guy completing it in 10 days, another one who will give us in 11 days. Can anybody do it in less than this time?
It is C plus 2, no, sir. Only 5 days sufficient.
Okay, only 5 days is sufficient. Okay. See, it's the architectural design. Okay, if it is in front of me and I talk to client for half an hour, then for me it would be what 10-minute job to give him the line diagram, and another 1 hour job to give him the 2D CAD drawing.
Yes.
Yeah. So, so this is what I think for architectural drawing, for the first drawing, right? But if you go for revisions, yeah, it could take like 10 days, If the client is not even ready to agree, then it could go for months also. Okay, anybody
Depends
else?
upon client requirement.
Yeah, depends on client requirement. But okay, so now you've got architectural drawing. What about structural drawing? How fast can you give it? Okay, somebody who is using software that has got interoperability, he would do it in 1 days, or somebody who is doing in manual and getting it checked would take almost a week or so, right? What about MEP? MEP drawings, how long it will take?
So we can do simultaneously, sir.
Okay, you are doing simultaneously. So after you finish the architectural drawing, one guy is doing structural and one is doing MEP. So how much time will it take to complete MEP drawings?
1 week.
Okay, 1 week. So everybody will finish MEP drawings in 1 week? I mean, MEP is like you have to go into detail for so many things. Like even for plumbing itself, all the components at all the levels.
So most of the part will be completed in structural design only.
Sir, if you're talking about MEP, then kindly tell me if you have to provide even AC fittings. Will you take care of AC fittings in structural drawing itself? No, you
While
won't.
while you are preparing structural drawings, you can plan for AC ducts and plumbing works.
Okay, so yeah, that is one thing that both these activities, let's name them A, B, and C, all three activities. You can once you complete activity A, you can work on activity B and C, right?
Right, sir.
Yeah. So what I'm asking is how long will it take to do MEP? You will be like, okay, if my structural drawing is good enough, my architectural drawing is good enough, I can finish MEP by 7 days, right?
Yes, agreed, sir.
Yeah. Uh, Now, while you are completing your architectural drawing in various time durations, 5, 10, 11, or even if your client is very specific, 30 days, did your resources change?
No, sir.
Then why is your duration changing?
So as we said and discussed earlier, as per requirement of client, it may be vary. So revisions are doing as per requirement of clients.
Okay. So do you think that this only depends on the revisions or requirement of client? Okay. So you know that even if you are not changing the okay, then you have got three values A, B, C for three activities. If I ask you, how long will it take you to complete the design part? What will you say?
Design part maybe uh, we can't be fixed in timeline.
Okay, but sir, we are discussing project planning, right? So at the planning stage itself, you have to fix some time. Otherwise, if your design part goes on extending and extending, when will you start your construction? When will you go
No,
for?
but as per my knowledge, design will be maybe change after starting the project also.
Yeah, yeah, that can change. But let's say we are talking about design bid build project. Like first you have to complete the design, then and only then you can go for bidding stage. So if I ask you in this scenario, how much time will you take to complete the design? What will you say?
If my project is 100 crores
Yeah.
design build, it will take a minimum 30 days, sir.
Okay. But sir, it is a G plus 2 project. So G plus 2, I would say let's limit it to 1500 square feet of plinth area. So 1500 into 3, right?
Again 5 to 7 days max to max.
Okay, max 5 to 7 days. But right now, ABC, you gave me some values, and that even itself, like if architectural design at the earliest finishes by 5 days, and MEP by 7 days, that means you can complete design earliest by 12 days, right?
Okay, yes, sir.
And if your architectural design itself stretches to 30 days, and then it will take 7 days again for MEP, so it will take 37 days. What you
Agreed.
see right now in front of you. So if someone asks you how much time will it take to complete the design, can you give it the exact value? See, from
Considering the architecture design will be 30 days, right?
yeah, I mean it can go on till 30 days, na? See, what happens is, from your experience you can say that okay, there have been a lot of projects that I have dealt with, but anyway, on an average, in 3 weeks my architectural design is complete, structural design 1 week, and MEP 1 week. So you can say that in 1 month my whole design process will complete, right? On an average,
Yes, sir, right.
right? So uh, this was a design process for something that has already been done. Okay. uh, this situation was in front of US military and NASA when they were designing a new missile. There are so many parts in a missile, so many new theorems, or even so many new designs they had to come up with, and they couldn't put a fixed timeline, right? Overall, let's say the US government gave them 5 years to complete the missile, and they were like 20 stages. Each stage, either I can get a result in 1 day itself, or by going iterative it can take 1 year itself. So they had like no way of planning for it or no way of quantifying it. This kind of probabilistic, converting the probabilistic durations into deterministic structure. So that gave the start for PERT. As you can see, the number of resources is remaining the same, all the conditions are same, yet there are some uncertainties, uncontrollable uncertainties, that is changing the duration. Okay, you should remember this, because when we talk about crashing, there would be uncertainties, but that would be controllable, and we would be changing the resources itself to crash the duration. Okay, so PERT, what does the most likely time represent? We saw here, right, 2177. So what does the most likely time represent? It is not the shortest, not the longest, the best time estimate under normal conditions, right? uh, Standard deviation in PERT calculations. What do you mean by standard deviation? Okay, we will see it if it is. Okay, what do you mean by standard deviation?
Amount of variations.
Okay, amount of variation. Okay, one thing.
Average amount.
Hmm? Can you repeat, please?
Average amount.
Average amount. Okay. So what we will do is, we will first look into the amount of variation, and then we will see if we can average it out, and then we will discuss standard deviation. Okay. Which probability distribution is commonly used in PERT? Probability distribution, this was in, like, for engineers it was in M1 M2, I guess, and also in 12th class, 11 12th. Which probability distribution is commonly used in PERT to model activity duration, not the whole project, activity duration? Okay, it is the beta distribution.
Normal distribution.
No, normal is for the whole project. Okay. See, what is the condition? Let this be 0% probability 100% probability and 50% probability. Okay, so okay, 0% and 100%. So you can have some value here. Okay, days, that let's say in there is no chance that you can complete the whole design in 3 days, and there is 100% chance that if you have given 60 days you can complete the whole design. Now what kind of representation you can have? You can have this one, right, left skewed, or you can have this one, right skewed, or you can have something in the middle. So but chances of having something in the middle is like only when it is planned, otherwise it is going to be either left skewed or right skewed. So this is beta distribution. Okay, uh, now what is the formula for calculating expected duration, the average amount for beta distribution? What time estimates you have got first? Okay, you have got, this is TO, most optimistic. You have got TP, and what is this, most likely, right? So what is the formula for TE?
TO plus 4
PO
TM
plus
TP.
4 TM plus TP by 6.
Plus TP by 6. Okay, so this formula is only valid if you have got either beta distribution curve or normal curve. Okay, if you have got a triangular, let's say in some exams or someone wants to play with you and say that the distribution, probability distribution is triangular in shape, then the formula will change. What will be the formula then? This becomes TO plus 2TM plus TP by 4. Let's say someone says that the probability distribution is uniform. Then it would be TO plus TP by 2. So as you can see that the formula varies as per your probability distribution curve. For beta or normal, it is going to be TO plus 4TM plus TP by 6. Okay, and in the same case, you can have activity A. Let me write some values for you. Okay, activity A, TO, TM, TP. So for activity A, TO is 3 days, TP is 20 days, and TM is 10 days. For activity B, uh, either you complete it in 7 days, 10 days, or 13 days. Okay, let's draw it out. So 3, 20, somewhere here you would have 10, right? And here it would have 7 and 13. So for activity B, for activity A, right? For activity A, you would be having a curve like this. For what about activity B then? For activity B, your curve would be like this, right? What does this mean? Even the most likely time can remain the same, but the spread is more, right? For activity A, either it could take 3 days or 30 days, but on an average it takes 10 days. For B, either it could be at least completed in 7 days or at most in 13 days, but can be done in 10 days. So how do we differentiate between these two? First you calculate the TE and then you calculate the standard deviation, right? So TE formula you already know, standard deviation standard deviation is TP minus TO by 6. Okay. Then there is one other thing. For one activity, if you have got, let's say this is activity P and this is activity Q, and uh, Q follows P, right? And there are two distributions like this. If you overlap them, don't you think that you will get something like this, that is towards the center? If one is left skewed, one is right skewed, almost similar parameters, then you would get something towards the center. Do you guys agree on this? Okay, this is the basic premise that we say that activity durations follow beta distribution curve and the whole project distribution follow normal distribution curve. Okay, normal distribution means centered, right? We will see this in numerical. But coming here, assertion, the critical path in PERT represents the sequence of activities with shortest durations. Sequence of activities with shortest durations. Reason, activities on the critical path have zero float or slack. So reason is true enough. What about assertion? Is it true? Is it false?
Both the assertion and reasons are true, and the reason is greater for assertion.
Which one, A or B? Okay, it does not represent the sequence of activities with the shortest duration. So assertion is false. So your answer becomes, I mean, I don't, yeah, there is no option here, right? E, assertion is false. Okay, so now solving one numerical. You have got TO, TM and TP. That means this is the question of PERT. What should be the first step here? What should be the first step here?
To calculate TE, sir, first.
Okay, so let's calculate TE. You all know the formula, right? So TO plus TP plus 4TM by 6. Help me calculate. I will write some values. You help me calculate others, okay? So this is 7, this is 6, this is 4. What about rest 2?
5.5.
5.5?
2.5.
Okay, let me check. This is what, 6 into 5, 30, 30 plus 3, 33 by 6. 5.5 is TE. And what about the next? 3, 3, 4.
7, sir.
For R. $3.16.
Yes, sir.
Okay, so let's also draw the network. PERT, I will be going with the AOA, simple itself. Is this the correct network? Is this the correct network? Can you guys follow? Or have I missed some logic here? Anybody? I just need someone to say if it is correct or not.
Correct, sir.
Okay. Thank you for the confirmation. So we have got two paths, right? PQ and RSU. What is our path length now? Yeah, I've got a raised hand. If you want to say anything, you just need to turn on your mics. Okay. So for PQ, it is 12.5. What about RSU?
12.5.
13.16.
13.1.
So which is the critical path?
RSU, longest path.
Yeah, RSU. So what is the probability of completing the project? Let me write it out for you. What is the probability of see completing the project in 13.16 days? What is the probability? The question is in front of you. Please help me answer. You just calculated some values, right? So what is the probability of completing it in 13.16 days? This is the critical path duration that you just calculated, total duration of the project.
100%.
100%. Okay. So sir, for activity R, S and U, let's say activity R, S and U complete in at the most pessimistic time. What is the total then? 18 at 16 days. It can finish in 16 days, right? Pessimistic time. So still you think that 13.16 probability is 100 days, 100%, or it should be less than?
No.
See, what you just right now calculated it is and this value you have got is 13.16. Okay, so that is the normal distribution, and you got t expected time. So what you have got is you have got 50% probability. Can you guys follow
Okay.
this?
Sir, it is always the
Huh?
most likely time is always 50%.
No, most likely time can follow beta distribution, right? What I'm talking about, expected time for the whole project when it follows normal distribution. I'm not going to detail of for
Okay, sir.
beta distribution.
Then our expected time always 50%.
Yeah, total expected time for the project it would be 50%.
Okay, sir.
Okay, so if it is 50%, then if somebody asks you what is the probability of completing the project in 12 days, you should be in the position to answer it, right? So for that, what you need to calculate is you need to calculate the standard deviation and you need to calculate the variance. Let's calculate these values. What is the formula for standard deviation?
Root of variance.
Okay,
TP minus T naught divided by 6.
Yeah. So TP minus T naught by 6. So this becomes 6 minus 3 by 6, 0.5. What about Q? 0.67, right? What about R? 0.16. For S, 0.33. And for S, it is for U it is 0.
0.
Yeah. What about variance? This is sigma. This is sigma square. Okay. I mean, it is standard deviation square. So 0.5 becomes 0.25. This comes up to be 0.45. This is 0.026. What about this? 0.33 square comes out to be 1.1 something. Yeah. 0.11, and this is 0. Right. So for this path, this is your critical path RSU. Right. So standard deviation for RSU will be under root of sigma square, right? But for which activities? R, S and U. So this would be point, 0.26, 0.026 plus 0.11 plus 0. How much is it? It comes out to be 0.37. Okay. So standard deviation is 0.37 for this path. So what you have got? You have got mu is equal to 13.16. Sigma is equal to 0.37. See, why you are getting so low value of standard deviation is, if you see for R, S and U, even their TO, TP and TM are quite close, right? For R and U there is 0, S there is some value, but for R it is very small. So that means the overall standard deviation for this path itself is very less. If you had calculated for the other path PQ, it would have got some bigger value, but in this case you have got mu and sigma. So if someone asks you, and that would be a question, that what is the probability to complete the project in 14 days? Okay, so for 14 days you have to follow this. You will be provided with this table, normal distribution table. How many of you guys are not familiar with this table, or what is actually happening here? Okay, a couple of guys. So let's try to understand it. What is Z? Z is equal to x minus mu by sigma. Okay, what is given here? Table value represents area to the left of Z score. Okay, so if you have got a let me make it more symmetrical if I can. Okay, that is the best I could do. Yeah, so if this is your mu, you know that this is the 50% for normal distribution curve, this is 100%. So area to the left here is this area, you would say it is 50%. That is what we did right now, right? So if there is some value Z here, sorry, some value X here, and you have to calculate what is the area towards the left, right? This is 0% probability, 50% probability, 100% probability. So for X, what is the probability of achieving X? It is the area towards the left, right? So that becomes your Z. How do you calculate it? you have been given 14 days. If your mu is 13.616, that means where should 14 lie? Towards the right of mu or towards the left of mu? 14 would be here, right? So 14 is here. That means you will have more than 50% probability. Let's calculate z. Z is equal to 14 minus 13.16 by 0.37. How much is it? 0.848.
2.27.
Yeah, 2.27. Now reading the table. So for 2, this is 2.2, right? And 2.27. So this brings us to this line. So what is the score? Value representing area to the left of x. Area is equal to 0.988. So if total area is 1 and area to the left is 0.988, then what is the percent here? 98.8%.
Yes.
So you have got
Yes, sir.
98.8% chances to complete your project by 14 days. Right? So can you guys do similar calculations now? I mean,
Yes, sir.
this is the this is the limit for this course. I mean, breadth wise, if we cover, and we have covered a lot of topics in this session itself. Okay, can you please explain the solution for question number 7 of assignment number 3? Let me check. Just give me a moment. Yeah. Uh, so, sir, do you want me to solve it for you, or want me to discuss the solution that has been given?
Actually, sir, I have solved that problem, but
Yeah.
I was getting the answer 6.1.
Okay.
So it was not matching with the option. So that's why I am asking for that.
Uh,
Discussions.
okay. Question number 7. The ratio of NPV you are getting 6.1.
Yes, sir.
Okay. So let me bring both the tables. Is the solution given here? Okay, the calculation is not given, right? So we will have to solve it for ourselves.
Yes, sir.
Can you help me make the table? Can you read the values for me? A company X has invested in infrastructure project. Assume initial one-time investment of rupees 1 lakh initial year. Then project cash flow is 10,000, 20,000, 30,000, 40,000, 50,000, and 40,000.
Yes,
Right?
sir. Yes, sir.
So let's draw the cash flow. A6, question number 7. No. Assignment 3. A3, question number 7. So if you draw the cash flow diagram, it would be 100 here,
Yes, sir.
then
10,
10,
20,
20,
30,
30,
then 40,
40, 50,
50,
and
then 40.
40.
Yes, sir.
Right?
Yes, sir.
Uh, so the question number 7 is the ratio of NPV of the project at discount rate of 5% and 15% respectively.
Yes, sir.
So NPV is equal to minus 100 plus 10 into this would be P given F, NPV at I,
Excuse
let
me,
me,
sir.
yeah,
Sir, actually, I have a doctor appointment. Can I leave, sir?
yeah, definitely, sure, sir.
With
Thank you
your
for joining.
permission? With your permission. Thank you, sir.
Yeah, thank you. Yeah, so uh, for 5 it would be 5 1 plus 20 P given F 5 2, so on, right?
Yes, sir.
Is this how you followed and not getting the right answer?
Yes, sir. I was following that formula. Sigma T2N cash flow at T uh, divided by 1 plus KT. That one.
No, no, no. No, no, you don't have to follow. You are not supposed to follow that formula. You have to calculate NPV at each percent, right?
Yes, sir.
So, if you calculate NPV at 5%,
Sir.
it would be given by this is zeroth year. So, net present value at present it is minus 100. For this
Minus 1.
10, if you bring it to 0,
Yes,
right?
sir. Mm.
How will you bring it? You will multiply it by P given F
P
5%
given.
1 year. For
Yes, sir.
bringing this 20, it would be P given F 5% 2 year plus
Yes, sir.
similarly 30. So if you follow this, I think you should get the answer should match.
Okay.
So my answer was 6.48.
Even by this, I mean, what method did you follow? Yeah, that can be one issue. What method did you guys follow?
So CF by 1 plus R to the power T.
Uh, okay. Can you can you guys write it for me somewhere or somehow?
So, is there any option to share the screen?
Okay, share the screen. No, I think there would be host control, but I would allow it. Give me a minute. Yeah. Can you share the screen now?
Yes, sir. Yes, sir. Sir, is it visible to you?
Yeah.
And
Okay.
this one, the formula I have followed, sir.
Yeah. Yeah, it should be. Side door and yeah, yeah. This is the one you should have followed.
Yes, sir. So I have calculated for 5% and then 15%. For 5% NPV is coming this one, and for 15% this one. So I have just calculated for these two.
Yeah, this makes sense. Mm, let me check by interest table.
Yes, sir.
Yeah, that means there is some problem in this, right?
Yes, sir.
For p given f. Mm, for 5%, 0.95 to 4, yeah, 0.18. Yeah, your values are correct. 0.774 into 5 again. Yeah, the that means there is some problem in the values that have been given. I will raise
Okay,
it
sir.
to the team.
Okay, sir.
Yeah,
Okay, sir.
thank
Thank
you
you,
for
sir.
pointing out.
Okay, sir.
Yeah, others also, are you getting the same values?
Yes, sir. 6.48.
Okay. Yeah, I will raise it to the team. Okay. So, any other question? Any other query? Or in this session, would you like me to repeat something? Okay. So this brings us to end of this session. Uh, Thank you guys. Thank you for joining. Hope to see you in the next session.
Thank you, sir.
Thank you.
Thank you, sir.
Guys, one more thing. If is there something you would like me to bring next session, something extra, you could let me know.